Hi, my name is Vasdev. I am a third-year medical student at the University of Minnesota, and today I'd like to share with you a little bit about our research using spectral analysis to objectively identify and quantify Detrusor overactivity. So urodynamics cystometry is really useful to identify Detrusor overactivity, which in the setting of our study, we define as a pathologic contraction of the bladder muscle wall prior to void, also known as a Detrusor contraction or DC. The identification and interpretation of DC leading to a diagnosis of DO is can be done through a subjective variable and often a qualitative process depending on a urologist's expert opinion and interpretation. There have been some previous attempts to quantify or measure DO, which has required manual scoring on the part of the physician or some changes to standard UDS filling protocols. So our research group has previously used the Fast Fourier Transform, or FFT, to derive spectral measures that are representative of bladder contractions, physiology, and pathophysiology under a variety of models looking at how it changes with bladder filling and stretch. So these models specifically are pig, an in vitro model of pig bladder tissue strips under various tension, a in vivo sheep cystometry model, and using routinely captured clinical data. But one question that we were wondering about was how can these spectral measures be used to detect changes with patients with bladder dysfunction, such as Detrusor overactivity or DO? And can these measures be used to, in fact, quantify DO? So the aim of our study is to use these spectral measures to quantify differences in bladder pressure spectra between patients with DO and non-DO using routinely captured cystometrogram data. So we screened 184 patients for a post-UDS diagnosis of only DO or only SUI. And we use SUI, or stress urinary incontinence, as our non-DO control, as presumably their urinary incontinence was due to extravesicular etiologies such as urethral hypermobility or sphincter dysfunction. And from that, we got a sample of 18 DO patients, 10 non-DO patients, which we conducted spectral analysis on using FFT, and derived two measures of such as spectral power, or SP, or weighted average frequency, WAF, within the frequency range from 1 to 6. Very briefly, spectral power is a measure of the sum of amplitudes within this frequency range, and you can think of weighted average frequency as the average frequency within the frequency range 1 to 6 cycles per minute. And again, we applied the FFT transform to UDS data. We derived these DO and non-DO spectral measures. And then we also conducted a exploratory ROC analysis using some multivariate regression models. In the interest of time, I encourage you to read our abstract on the results and interpretation of these models. So let's walk through exactly how we got these spectral measures. So let's take a routine cystometry here. We can clearly see, and I'll get my laser pointer, these detrusor contractions over here. We filtered it for movement and cough artifacts, divided it cleanly in half with into early and late filling segments, applied FFT for the frequency range from 1 to 6 cycles per minute, and then subtracted the FFT from the vesical signals from the abdominal signal to isolate here in green the bladder pressure specific spectra. And then from this resulting spectra, we gathered the spectral power and weighted average frequency, and you can see those values here for this particular patient, RU being relative units and CPM being cycles per minute. Let's do the same thing with the non-DO patient. So import their data into MATLAB, filter for movement and cough artifacts, divide into early and late, apply the FFT spectra for the same frequency range, and then subtract the two spectra to get bladder-specific spectra, and then calculate the spectral power and weighted average frequencies. Again, you can see those values here. What I would like to do is take these green histograms, or the bladder pressure specific spectra, put them side by side, and just for a visual comparison of the two. And please note that the amplitude difference is a factor of 10 difference between the two. So in the DO patient, we see that there is predominantly more lower frequencies, and the amplitude is much higher when we compare it to the non-DO patients, which have a little bit of a higher frequency center and a lower overall amplitude. This corresponds to what we see with the spectral power being higher in the DO patient, and the weighted average frequency being lower in the DO patient compared to the non-DO patients. When we apply this methodology to our N of 18 DO patients and 10 non-DO patients, you can see the raw values here in the subplots A and B. But I'd like to zoom in on the summary, the means, and the standard errors in subplots C and D. What we can see is that there is significant difference in the spectral power between a cross-filling for both measures. So more specifically, spectral power is higher in the DO patients across early and late fill when compared to the non-DO patients, here in orange, DO is in blue. However, when it comes to weighted average frequency, that is lower in the DO patients significantly when compared to the non-DO patients. In all comparisons, we're using a one-way t-test. So in conclusion, these spectral measures are able to both quantify and demonstrate differences in DO compared to non-DO cystometry across filling segments early and late. We do believe that these changes are primarily driven by the Detrusor contractions themselves, and this will be a topic of future work for us to verify that. But as a whole, we can then say that spectral measures are a potential viable means to one, automatically quantify DO and also objectively quantify DO, most importantly using routinely captured cystometry data. So thank you very much for listening. Please reach out if you have any questions or want to chat. My email is here, and you can also find me on Twitter. Thanks.